What's up guys, Onmaths here, and today we're looking at Pythagoras' theorem. Now, all of the questions we're covering today, or well, the second and third one definitely, will involve other topics, and generally speaking on the higher paper you don't generally just get a Pythagoras question and then that's it. It's normally mixed in, normally with trigonometry and other topics, so you'll see that on question 2 and 3. So if you feel like you're an expert in Pythagoras and you struggle a little bit with questions 2 and 3, it might be because of the different topics they're from. However, let's get started. So this is an AQA question, and this is a question about someone doing something and then making a mistake. So it says, what error has she made in her working out? The best way of doing these types of questions is just do it yourself, and then hopefully you come across the mistake, and try not to look at this bit here. Otherwise you're just replicating the mistake. So Pythagoras says this squared equals this squared plus this squared. Okay, so 2y squared, and it's all of that squared, equals 6 squared plus 8 squared. Let's get our tram lines in. Okay, so the first thing we need to do is get rid of the squared. So we're going to square this bracket. So 2 squared is 4, y squared is y squared, 6 squared 36, 8 squared 64. Then we might as well add on the left hand side, why not? So equals 100. Then we need to get rid of this 4 here, so we're going to divide both sides by 4. So divide by 4, and so that'll be y squared equals 25. And then we're going to square root both sides. So y equals 5. Okay, so what did they get? Well, they got y equals root 50, so they clearly didn't get the same answer as I did. So we just look back and see what steps are the same, what steps are different. So this step here, let's highlight it, this step here is absolutely fine. In fact, fine, let's make it green. That one's fine, because that's the same as mine. But this next step is not fine. It's not the same as mine. So we've got to figure out what they did. Well, I squared the bracket out just as they did, but I squared the y and the 2. You've got to square both of them, because 2y squared, so 2y, all of that squared, is the same as 2y times itself, right? Times 2y, which is 4y. And they got 2y squared. Something like, when she squared 2y, she should have got 4y squared. Something along those lines. So she hasn't squared the bracket, has only squared the y, the brackets have been left out. Something along those lines will get you the marks. Just make it clear, and I would always write 4y squared, make sure that's in there, because I'm sure that's in the mark scheme. Part B says Kai works out that y equals 5, which it is, thankfully. But Mel says y can't be 5 because the hypotenuse must be the longest side and the other sides are longer than 5. Let's have a look. So that cannot be 5 centimeters, because then it's not the longest side. Now Mel is right with that, however that is not y, that is 2 times y. Okay, 2 times 5 is 10. So is Mel correct? No. And something along the lines of, because it is 2y, which would be 10 centimeters, or something along those lines. Just make sure that you highlight the fact that it's not y, the hypotenuse is not y, it's 2y, and that will get you the marks. Alright, next up is Edexcel's contribution. So we've got quite a difficult problem here, made more difficult because there's no diagram. So the first thing I would do is attempt to draw a diagram. Now, I'm not going to do the most inspirational diagram in the world, but I'm going to try my best, and I've got a little circle here that hopefully will work. Doesn't work too well. It'll do the job. Right, so we've got a square inside a circle. So let's draw that square. It doesn't have to be perfect. Something like that. Okay. So we've got a square inside a circle. We know the area of the circle. Now, what I do know about this square is its diagonal of the square is the diameter of the circle. And what we also know is with this piece of information, the area of the circle is 49 centimeters squared. We can actually work out the radius because we know the area. So area equals pi r squared. If the area is 49 equals pi r squared, then I can get my lines in and I can work out what the radius is. So the first thing I want to do is divide both sides by pi. And I'll just leave that as 49 over pi for now, equals r squared. Then I can square root both sides. Okay, so I can do square root 49 over pi equals the radius. So I've got the radius, but the radius is obviously only going to be halfway across the diagonal. So to work out the diagonal, and always show the examiner what you're doing, we just need to do 2 lots, or 2 times the radius, which is 49 over pi. So 2 lots of that. So the question tells us that the length of the square is x, and it's obviously a right angle triangle. So we've got the diagonal, which is 2 root 49 over pi. So we can write that on. So 2 root 49 over pi is this length. So we just use Pythagoras, which is a squared equals b squared plus c squared. A squared, well, a is the 2 root 49 over pi, and we're squaring all of that. And b and c are just x, so it's x squared plus x squared. Simple as that. So when we square this bracket, as we learnt from the previous question, we square this and we square this. And you could do it all in the calculator. Obviously it's over pi. And we've got 2x squared there. That works nicely. Okay, let's work out this as a fraction. So 4 times 49 over pi, which we know will be if I can do it. So it would be 196 over pi. Just tidy up our working out a bit. Okay, let's get our lines in and sort it out. So we're going to times both sides, or divide both sides by 2. So we get x squared. And when you do that, you just divide the top of the fraction by 2, don't you? So 98 over pi equals x squared. And then we're going to square root both sides. So I'm going to type in square root fraction 98 over pi. And it gives 5.585 blah blah blah. It's equal to x. Now the question itself says that it wants the answer to 3 significant figures. So looking at that, that's going to be 5.59 to 3 significant figures. Last up is our OCR question. Lots going on here. It's talking about similarity, and as I said, with the second and third question today, we're going to involve slightly different topics as well. Okay, it's very rare to get Pythagoras on its own, but essentially, if we know what this length here is, then we can work out whether the two triangles are similar. So we're just going to call this, I don't know, x for now, and we're going to work this out. And so we know that a squared equals b squared plus c squared. A squared is the hypotenuse, which we've called x, so it's x squared equals, it doesn't matter which way around we do these, so 4 squared plus 8 squared. So we've got x squared equals 16 plus 64, so we've got x squared equals 80, and then we get our lines in, and we square root both sides, and we've got x equals root 80. Okay, so if that now Let's get rid of that x, because we know now that's root 80. Oh, hang on. Okay, let's get rid of that, and then let's put in root 80, which is this one. So we've got two triangles now, and let's try and draw them the same. So we've got the triangle at the top, which is 4, 8, root 80. And let's draw the other triangle we've got at the bottom. And we know that that is root 80, and that is 10. Now, the rule says that if you have two pairs of corresponding lengths in triangles, then the triangles are similar. And what I mean by corresponding is that you times one by the same amount to get to the other. Okay. So we're going to start off with the hypotenuse, because we've got to show that. So we've got to figure out what I times that by to get to that. And so the way of doing that is just 10 divided by root 80. So bigger one divided by smaller one. And that is 1, well, I might as well just do it as a third. So root 5 over 2. Okay, let's try it with the other one. So this one to get to this one. So we're going to do root 80 divided by, get out of that, root 80 divided by 8. And that is root 5 over 2. So there's a common scale factor. So I don't know, we could write that down. So common scale factor of root 5 over 2. Now we could work out this length here by using Pythagoras again. And we probably should. So why don't we finish it off? And let's check the last set. So let's call this, I don't know, y. And so it would be a squared plus b squared. Oh, a squared equals b squared plus c squared. A squared would be 10, so 10 squared equals, and it doesn't matter which way around we do, so y squared plus root 80 squared. And so it'd be 100 equals y squared plus 80. So we're just going to take away 80 from both sides. And this would be 20 equals y squared. And then square root both sides, square root them. And so we've got root 20 equals y. Okay, so that last one is root 20, so let's get rid of the y. And we know that that is root 20. And so we've got root 20 here. And so we just need to show that it's the same ratio. And so we do root 20 divided by 4. And yet again we get root 5 over 2. So if all three lengths are, you just multiply them by the same amount to get to the enlarged version of the shape, then the two shapes are similar. Now similarity is not congruence. It doesn't mean they're exactly the same size. In fact, clearly we can tell that they're not, but it just means one's enlargement of the other. And so if you show that the three lengths on the smaller one has the same scale factor to get to the bigger one, then you've proved that the two triangles are similar. Well, I hope you found today's video useful. If you did, please click like. If you want to see more from us, click subscribe and click the bell icon, and you'll get all of our videos, which we release them every single weekday, Monday to Friday at 9 o'clock in the morning. At the moment anyway, for the summer school. If you want to see more from us, check out our website, onmaths.com, with loads and loads of free resources. You can sign up for free. Everything on the website is completely free. Otherwise, thank you very much, and I'll see you tomorrow.